So in this problem, we're asked to prove that the torque due to the force of gravity will act as though it acts as a single force at the center of mass. So in order to prove this, we're going to use the fact that torque is equal to R cross F for a single force, and for a number of forces, the total torque is going to just be the sum of Ri cross Fi across all forces and all distances I, so that we get all of the torques added up for a single system. So in this case, since we're only worried about the force of gravity, we're going to just think about the sum of the force of gravity over as many different little pieces of the object as we can. And so since the force of gravity is equal to mass times gravitational acceleration, this is going to be the sum of Ri cross Mi g. I'm going to give g a vector since it's going to be acceleration pointing straight down. And since we know that the cross product can have constant coefficients factored out of it, we're going to factor out the mi and move it over to the other term. So this is going to give us the sum of mi Ri cross g. Now since g is also a constant, we can factor that out of the sum as well, since the cross product has that property. So that means that rather than being the total sum of all of these individual cross products, this is actually just the single cross product of all of these smaller sums cross g. Now this sum right here should look very familiar to you. That's actually the center of mass sum. So this gives us m, the total mass, times the center of mass. So that's going to be RCM. Because remember, the vector RCM is going to be equal to that sum divided by the total mass of an object. And then this is going to be crossed with the gravitational vector right there. So now, again, we can move this constant coefficient, this mass term, over into the other side, and this gives us RCM cross mg, which is exactly equal to RCM cross the total force of gravity. And so this is exactly what we were trying to prove. We were trying to prove that the torque due to gravity on an extended object acts as if it is a single force of magnitude big mg that acts at the center of mass. And that's exactly what this expression is telling us. This is the radius, or the distance vector to the center of mass, crossed with the total force of gravity upon the entire extended object.